Hi friend, in this video we are going to learn about the tail recursion. First question comes in mind that why we are using the tail recursion. Because what we have seen that when you go for the recursive process, it will be increase your time complexity as compared to the iteration. So that reason you can go for the tail recursion. Before going for definition of tail recursion, I will explain the process and then I will go for the definition of tail recursion and different types of recursion. We can see here what we are doing here. We are finding the factorial of a given number. If n equal to 0, this is a base case and this is the recursive case. See here how the function is calculated the value. First n is there, then suppose n equal to 4, the 4 is there, multiply by n minus 1 means 3. Then again it will be called back. So 3 f2 will be calculated and f2 is calculated here 2 into f1 and this will calculated 1 into f0, and then when 0 will be called here, the 0 become the 1. So here 1 will be written. When 1 will be written, again it put the value of f0 equal to 1, it become the 1 into 1 there. So whatever the value of this one, it will be put here because this is the value of the f1. So 2 into 1 will be calculated here. Now this value will calculated, this value will be put into f2. So in this way it will be calculated. Now this value will be put here. Finally you can get the 24 or the n equal to 4 there. So what we are doing here, we are going in recursive way, store the value in step 1 by 1. After getting it, we are putting the value in the backward direction to get the final result here. So here you can say that when the function in the recursive go, then your stack size will be increasing. So try to overcome this problem. We can go for the tail recursion. We can see here same factorial function, we have called the fact n, integer n, and then the fact 1 means another function. Here what we are doing that here we are passing that n and the 1. Now come to this part. This part is known as the your integer n, same, and the result is the your, you can say, one auxiliary storage that will be stored the result in a current execution. Suppose here I have and the remaining same thing. If n equal to 0, return the result, otherwise return in this way. Here you can see the difference. In earlier case what we have written, n equal to fn minus 1. Here what we have written there, return equal to, this is your fact 1, n minus 1 into n into result. Alright, so here what we are doing that every time whatever the value of the n, we are calculating and store the value in the result there. We can see here, suppose n equal to 5. So how it will be executed? So n minus, because it will become here n 5 1. So here n is 5 and r become the your 1 there. N equal to 0. So it will become not satisfied. It will become in this part. This part n will become 4. You can see here, and n is the 5. We know that, and then multiply by the 1. So this is the your store in this part. Second time it will be called. So it become the minus 3. So what is the result of this is 5. 5 will be come to this part. So this 5 is there, and multiply by n. So now n is here. 4 will be multiplied with this one. Now you can see that 20 will be stored in a result there. In this call 2 will be there because n minus 3 is there, so it becomes the 2, and 3 multiply 20 because here result is the 20. 20 multiplied by the n is the here 3 there. So 60 will be stored in a result. Here you can say 20 will be stored in a result there, and here result means 5 is stored. Why? Because here we have written that the n multiplied by the rs, and that value will be passed to this rs. In this case, what is the value of result? 60. Now the n equal to 2 here. So 2 multiply 60, 120, and 1 will be here. Now what is the value of rs here? 120 there. Now the here 120, it become the 0 and become the 120 into the 1 there. Now when the 0 match, next time it will become, next time 0 will be match. So you can say that it return the rs. Rs means 120. So what is the difference between these two? Here what we have done, after the value of the f0 equal to 1, we are putting back and we are getting the result. But here what we have seen this, after the your base condition satisfied, we are direct getting the result. So what is difference between these two? In first one, what we have seen that the after the putting the value, when the base condition satisfied, we have to backward direction to get it. But here, when the base condition satisfied, we are getting the your result there. So tail recursion means a recursive function is the tail recursion when recursive call is the last thing executed by the function there. Means when it will be returned, it have not do any pending work. It will be direct give the result there. Here what we are doing that when it will be result, it is giving the your pending work there. Think about the semester exam there. In semester exam, I can give the copy, write the answer there, and the answer submitted to the examiner. Examiner will be check it, and then result will be published. So it is too much task. Means after completion of my examination, examiner will check it, and then it will be give the result, and then we are able to see that. But in case of online, after the completion of the test, I am able to see the result there. So tail recursion is same as the your online version of the your result, and this is the your just like the traditional way to get the result there. Now you can go for the different type of the recursion. You can see the type. This is the direct, indirect, tail recursion, Linear and tree recursion. So when the function call itself, you can say that direct. When A calling to B and B calling to A, so this is the indirect there. Tail recursion, I already mentioned that a recursive function is tail recursion when recursive call is the last thing executed by the function. Means it will be not done any pending work as compared to the null tail recursive. Now we can go for the linear. Linear means what we can see here. After this one, we have to calculate this one, calculate this one, calculate this one, calculate this one, and put this one, this one, this one, this one. So this is a linear. You can go fact 3, fact 2, fact 1, fact 0, then fact 0, fact 1, fact 2, fact 3. In this way we are calculating. So these are the linear way to performing the recursion call. Tree means in case of Fibonacci, you can see that this condition, if n equal to 0, return 0, otherwise it return. If n equal to 1, return 1, otherwise it will be go for the this condition, means n minus 1, n minus 2. Suppose I have taken the f equal to 3. So 2 call f2 and f1 based on this. f2 is f0 and f1 because this condition will be satisfied. So here you can see this is like the tree structure. This is a parent, these are the child, and these are the child of this parent. So this is the meaning of the tree recursion. I hope that we have understand it.